Good morning, everyone. Great to have all of you here. So grab some seat and everything as well. Will be great. So I'm Hin. Basically, I was asked to introduce our next speaker, which I'm really glad to be. So I'm from the Waikato Uni, and I've been in collaboration with Steve, which is our next speaker, for a couple of years. He's the CEO and founder of Robotics Plus. And you'll get to see a lot of nice videos and a great talk coming up soon. So let's have Steve coming up. Thank you.
Tēnā koutou, everyone. So this will be the most non-technical talk of this whole event because I'm actually just a grower. I've been growing food crops for 36 years. So really, the robotics is really something that we started a number of years ago to think about our longer term sustainability. And, you know, our purpose really is around helping the ag sector adapt to the demands of a changing world and to sustainably thrive, not just survive. And there's a lot of pressures on farming now, everything from environmental, water, labour shortages, increasing costs to produce, yet the food price isn't keeping it at that same inflation rate as an increasing cost to actually operate, you know, a farm or an orchard. So a lot of pressures with all sorts of areas in that ag, and you know, and there's a growing demand for food. So it's a really interesting and challenging problem. You know, our view is around bringing this power to adapt and really what we're trying to do with the build of our robotics for the farm, the field, the factory, in dynamic environments that demand adaptability, practicality and commercial viability. And that commercial viability is a really important point, that these are really low cost things that we're trying to replace. You know, we're replacing often the cost of a labor unit. So we have to create technology that makes a return on investment that is sensible to a grower to adopt. And our robotics is really about not just to solve, but to learn and adapt through artificial intelligence. So super smart tech solves complex problems simply and easily. And that's the other piece, is the easily piece, because we can't give farmers complex things to operate. You know, often in the US, everything we do has to be translated to Spanish. If it can't be read in Spanish, it's not going to operate because, you know, a lot of the workers, the field operators are Spanish people. So a lot of education we have to do alongside of this. I'll just give you a quick little background to RPL, and then we'll get into some of the areas that we're developing. Sort of how we got there. As I said, for myself, I own orchards, I own pack houses, cool stores. I've done and worked in every part of the supply chain through my career. From still got my first pay slip for $3.18 an hour, sweeping floors and potting plants. From there, built a number of agricultural startups over the years. And still very highly engaged in the production systems. And probably about 10, 12 years ago, I sort of wondered what was happening in robotics, which was sort of quite unusual for agriculture. So I went looking around the universities of New Zealand, and I found the fella on the next to me on the slide, Alistair. He had just finished his degree with first class honours in mechatronics, and he wanted to do a PhD. So I sponsored that PhD for 5 years. And what we set him to do was to prove to me that we could have an autonomous vehicle go through a kiwi fruit orchard and pick kiwi fruit. And that's what his PhD thesis was. So in about 2013, he completed his PhD and proved to me that we could do this. So I said, let's start a global robotics company. I gave him 50% of the company, and we've been on a journey since then. In 2018, we attracted Yamaha Motor Co. as a founding shareholder in our company. And that was very strategic for us. What we wanted to learn from Yamaha was one, hey, we're a cool little company from New Zealand. We've got a global brand invested in us and beside us, but it's also, we were really interested in what Yamaha had to offer around all sorts of things, from design for manufacturing, production systems, their huge networks that could introduce us into lots of areas around the world. So, you know, they run programs with all the major people like NVIDIA, et cetera, and it allowed us to elevate up into those, being at the forefront of testing some of those new technologies that were coming out of their partners. But also they gave us access to components and technologies that a small startup could often not afford. So they've been a huge partner for us throughout the years. In fact, we work with a lot of their divisions all around the world, and they support us in lots of ways that are actually non-dilutive cost to us as a startup. We also had ACC make a small investment in us in 2020, and we were their first impact investment. And that was really on the basis that we were removing people from dangerous situations. ACC, for those who aren't from New Zealand, is the Accident Compensation Corporation. It's what funds a lot of healthcare for accidents in New Zealand, but they also hold the largest fund in New Zealand, which is $40 billion. And their whole premise is about supporting companies that are doing good for people and removing them from harmful situations and reducing accidents within the environment. So as you see the tech we're doing, you can see how we're impacting that by removing people out of those sort of dull, dirty, dangerous jobs. And then New Zealand's a unique place where we have a lot of government support and opportunities, everything from institutions like Callaghan Innovation, who can fund R&D, co-fund R&D projects with you, to the likes of New Zealand Trade and Enterprise will help you into market and quite significant market support. And then also we have things like the Ministry for Primary Industry, who have some quite significant funds around sustainable farming. And they'll fund up to 40 to 45% of quite major projects over a number of years. So, just to give you a scope of that, we're currently in negotiation with them on a $32 million project where they fund 45%. So, really great support here in New Zealand. And then, of course, we work closely with a number of the universities across New Zealand as well. For us, our team is the key to our success. We're creating technologies that are in very complex environments. We're not a robot in a factory. We're actually, well, we do have some of those, but most of the work we're doing is we're actually going into the environments. We're dealing with natural structures. We're dealing with wind, rain, mud, light, all the different things you could imagine that you'll find out in an orchard. And to really integrate these technologies, there's a number of areas and disciplines required to pull this together. Everything from mechanical, mechatronics, electronic engineers, electrical engineers, design, software engineers, data. We have a number of specialists in vision and navigation engineers. So we really brought a significant team together. The slide's a bit outdated. We're sitting closer to around 120 people now. And we've got 9 summer interns in the organisation for the next 4 months that are all doing nice little projects. And just before we get onto the cool tech, is we really like to work with meaningful partnerships. Getting technology adopted globally is quite challenging, and particularly in ag, because it's not scalable. It's not a SaaS play. It's not like we're selling iPhones. We're selling smaller numbers of quite specific machinery for specific tasks. So, as I mentioned, we have this great relationship with Yamaha Motor Ventures in the US, who, constantly keep us in tune with what's happening in the startup world, how what's being funded, where our competitors are. But then we work with a number of companies to really integrate the technology, like ISO, that's a port logistics company. We'll show you some of the things we're doing there. And they're owned by Cube, which is the largest port logistics company in Australia. And then they go further globally. So with those guys, we do contract R&D. We own the IP, then we roll out the hardware, and then they pay us a royalty for everything we do. And we've got a 5-year roadmap of technology development for that on port. So it's very helpful when you're an early stage company. Companies like Global Pack Technologies is combination of people like Van Doren in the US, Jenkins Fresh Pack from New Zealand, and a number of their relationships globally. And they integrate our fruit packing technologies that I'm about to show you. And that for us is we don't have to set up service people, we don't have to set up installation, and we're just a small part of a big chain. So they know how to best integrate our technology into a bigger play. So it's all about how you use smart partnerships to get that technology into play with growers. And then, as I said, it's just the support we have from the government agencies, and we're very engaged with a majority of the universities in New Zealand, particularly with Waikato and Auckland, and we support a lot of the projects that they're doing, particularly in the ag field. And for us, that's really important. We're looking for our future talent pipeline. We're looking to see how the young people within the universities are thinking about solving the problems. So it's a really important and powerful thing for us. So the main development areas that we focus on is sort of around packhouse automation, port automation, and unmanned ground vehicles. So it seems quite a diverse lot of things we're doing. But what we've actually developed over time is a lot of what the technologies we've created in each of these fields is transferable between the fields. So we've really taken a modular approach to how we create the technology. So we can take what we're doing with vision systems in the packhouse and use those vision systems in the port automation, what we're doing with unmanned ground vehicles and being able to use that into port automation. So we're making sure that everything we're creating can be transferable, so we can start to plug and play, and we can cover more things quickly. So if we look at packhouse automation, this is really simple play to replace the endpoint where labour stands doing a meaningless task. And so these are our Aporo robotic packing lines. And what we're doing in this space here is we're stem and calyx orientating the fruit. We're putting the best colour side of the fruit up. We're also been able to identify the pocket, the tray type. So there's a lot going on in here in terms of what we're doing. And these are all things that normally people would just be standing there looking at the fruit, orientating them, choosing the best color, and we just automate that process. And we replace 1 to 2 labor units standing at each of those stations, which is, doesn't sound a lot, but when you talk about the US, when they operate those pack houses 12 months of the year, 2 labor units can be costing them $110,000 to $120,000 a year. So it actually stacks up very quickly in terms of being able to solve a really positive return on investment. And you can see here all the things we can do. And what's interesting is the pick and place robots you see there, we developed those. Yamaha actually assemble our technology for us. So they assemble the pick and place robots, send them to us for production. So it's pretty cool having a company like Yamaha doing that for us. And what you see here, this is just a screenshot. So all our technology is connected. So wherever these machines are in the world, we can log in anytime. We can actually look through the cameras, look at the fruit being packed, what type of variety, all the data we're collecting. We can give analytics straight back to the customer on, how much fruit was packed on average per minute for the day, all those sorts of things. But what we're doing is we're really using AI to analyze the video feeds from both the fruit orientation pockets and the tray cameras, and each frame is run through neural networks to identify key features. And we detect the presence of fruit ready for orientating or being queued for orientation. We recognize the features of the fruit, such as the stem, the calyx, the stickers, and the cleft structures of the stone fruit that you saw. This machine not only is packing apple, we can go across other crops. So you saw the stone fruit in the video, and we can identify the pockets or previously packed fruit on a tray as well. So a lot going on with the system, and the system combines this information to manipulate the fruit into the ideal orientation, then directs the robot to carefully place the fruit into the optimal pockets available. And it can arrange the fruit to be blush side up, improve quality, perception, or change the angle of the stem. So we can, you see the dial there, we just dial around depending how the person wants to present that fruit. You see down the bottom, you have an off to performance. So that's whether they want really high quality presentation. So they go right up, slide that up to performance quality, which means the machine just goes a little bit slow to ensure it's all the best color up. And then you can do box avoidance, so we can pack tray and box. The technology is smart that no matter what tray you put in there, it can recognize where the fruit needs to go. So you could tear that tray in half and throw it in sideways and it'll still pack the fruit perfectly. So very, very adaptive machine. When we look at port automation, this is our fixed gantry log scaler, and the problem we're solving here is that exporting logs is all about the small end diameter of the log by the length of the log is actually what quantifies the payment for the amount of millable timber. And this was a process where trucks would come in, people were standing on platforms using an electronic tape measure to take two measurements to decipher the circumference of the log. So what we've done here is we created a gantry robot. You saw that gantry as it went down the truckload, the LiDAR is scanning where the packets on the truck is, then the camera bar then drops down, and we take a series of images with 8 stereo pairs of cameras, and we're able to stitch all those images together, including reading the barcodes, and then all that information is just loaded straight up into their system. And you can see there the AI algorithms just going right up. We're at 99.5% accuracy. We're too accurate. They actually have in ag, they have quite a tolerance. And we do that task now. A truck pulls in and drives out in 3.5 minutes. And that used to take 2 to 3 labour units, anywhere from half an hour to an hour to do that truckload. So significant savings. And the model we have with them is they share that labour saving with us. So we get paid a royalty for every tonne of logs we scan. So it's a recurring revenue model. We sell the hardware at an agreed margin, and then we just get a check every month for the logs that we scan. It's very cool. So the key features in that is then they came to us and said, well, we don't only have trucks, we have trains. So this is the beautiful port of Tauranga, and you can see there's a lot of logs flow out of Tauranga. We have those fixed gantry scanners in virtually every port in New Zealand. So 70% of all logs out in New Zealand run through our technology, and then we're implementing the fixed gantry scalers and technology sort of on the global stage now as well. This is our sort of mobile version. So what we were able to do here is take that scanning technology that we had on a fixed gantry and adapt it to our autonomous vehicle technology. And we've actually even further adapted this technology now, where we don't have to scan the load before we go back and do the cameras. It detects the packets on the fly. So there's a lot going on, and that's fully autonomous, and it's a full electric vehicle. And you can see how we're using a lot of the sort of LiDAR and vision systems to, correct our courses as we run down the rakes of rail carriages. So again, this is and these machines have to be able to handle, we get huge winds on the port, we get rain, we get lots of different light. So there's a lot of complexities when we're doing this technology that we have to account for and ensure we can deal with all sort of environmental things that are thrown at us. So you can see here, it's a very busy place, and this was a job that they had people climbing over trains doing the same thing as they were doing over trucks. So you can see why this becomes really important in port logistics around solving some of these problems. And, ports have a number of deaths on them over the years. So, this is, that's what we're really excited about. And then we sort of move into our unmanned ground vehicles. And what we're doing here is, this is a beautiful vineyard in the Hawke's Bay. And what we're doing here is really automating a lot of tasks that normally people will be sitting on tractors in spray suits, been in that spray environment. So these are fully autonomous vehicles. They're hybrid electric. So essentially a diesel engine that runs a power generator, but the vehicles are fully electric. So the only servicing a client has is a standard diesel engine oil change. And not only that is that diesel engine is really only idling to generate power. It doesn't run at a normal tractor high revs. So we can expand the operating hours significantly. So 100 litres of fuel can see those machines run for over 12 hours operationally. But battery technology in ag is really challenging. Once you put an implement, you're running fans or running mowers, you drain that battery power very, very quickly. So you'll see companies like Monarch tractors, for example, that you have to change the battery every 3 to 4 hours. And a lot of farmers aren't ready for electrification. If you could imagine a farm, I deal with clients in the US who have 300 tractors. You imagine they'd have to have a Walmart car park with superchargers over that whole car park to plug their tractors in every day. And that sort of electrification is not even available in those rural areas. So the hybrid approach is quite significant. So you can see here, busy, we can run a fleet of multiple machines with one operator. So one person can control 10 machines. That's where the real labor saving comes in. Instead of having 9 or 10 operators drive a machine, you have one guy with an iPad operating 10 machines. Secondly, the machines are a lot more efficient because we can turn row to row. We're not looping around. We're very precise. The machine is deadly accurate. If it's set at 5 k's an hour, that's what it does all day long. So we can reduce the amount of tractors we need by probably 30%. We can reduce the operating costs by 50%, and we can reduce labour significantly. And then the great thing about New Zealand is, we're counter-seasonal to the US. So you just saw us testing in a beautiful vineyard in Hawke's Bay. Now we're testing, doing demos for customers in Napa Valley in California. And you can see totally different environment, dusty, dry, high temperatures. So again, you can see, how we have to test these in multiple environments and really understand what's happening. And the spray technology on the back of this is just really, it's a standard sprayer that they use in that industry. It's terribly inefficient, and it really gives no ability to control anything in what you do. And what I'll show you shortly is sort of how we're sort of adapting new smarter technologies that can actually apply based on canopy density, and we can reduce chemical use significantly as well. But you can see that sharp turn there, row to row, that adds real significant savings, because most people have to go out and miss a couple of rows and then loop back round. So when you add all that time up of all that looping, it's quite inefficient. You can see very safe. We have a large number of safety systems in there, a number of redundancies. So we have everything from LiDAR, object detection, camera object detection, safety bump bars, kill switches, because we have to meet a lot of safety regulations. And we've also got to cater that if we lose certain communications, that we have another redundancy that can kick in. So, when you think about this, the first picture is what the vehicle can see, with LiDAR alone, which is great for detecting solid obstacles and their position in space. But the real power comes from adding that layer of intelligence on the top of that, using the view from the camera plus a neural network to classify the objects in real time. So you can see that difference there, and how we can take that LiDAR image, fuse that with our camera, and then we're starting to be able to really identify our objects in real time. And that starts to allow us to do a whole lot of things like sensing and tasking. So we can be looking at that canopy density. We can be starting to target spray exactly where that density is, as opposed to that previous sprayer where you're just spraying everything as you go and you've got no control. And in the image above, the neural networks identify posts, foliage, ground and trunks, and can use this information to keep the vehicle moving at top speed in the center of the row. But it also is where we can tag all our object avoidance pieces as well. So it's a mixture of a lot of things. And I just thought it'd be really good to show you a little bit like in apple orchards, the variations that we're dealing with. What you see there is a traditional growing structure of freestanding trees, a lot more complex because they sort of stick out everywhere, and you can see the fruit hanging all over the place, to a more vertical growing structure where they're trained in a more 2-3-dimensional way, and then you have a V trellis structure. So, you know, everything we're doing, we're having to deal with these different growing structures, and then thinking about how we sense and task in each of those growing areas. So with the new configuration, so the picture on the right is our next production lease. So the vehicles I showed you in the videos was all our prototyping, working in those environments for a couple of years, and our new production machine rolls out next year, and every machine's sold already. So we've got some big customers in the US, and you know, the thing they give us is, here's 1,000 acres, automate it. So that's like putting 16 machines into 1,000 acres as a first pilot for a customer. So it's pretty exciting, but also pretty challenging. But you can just see there how we, you know, this is a sort of new technology of spraying. We've really taken traditional spray technology and modified it. We've electrified it, but we've also able to build a huge amount of sensing into that. So every one of those fans we can control. Within that fan, we have multiple sets of nozzles and control valves, so we can variable rate spray from anywhere from 5 litres an acre to 2,000 litres an acre, without having to do any calibration or changes. It's just automatic, and we can place that off reading the density, and then it's just adjusting based on density, and we're targeting that spray right where we want that spray to be. So if you look at that apple tall tower there, we can basically control every meter zone on that tree. So we can be having heavier chemical application at the base of the tree where the trunk is, and we're more apple density. And by the time we get into the top of the tree, we're doing very light spraying. So that's where we can start to save significant chemical use in orchards, which is a lot better for the environment. But our platforms are also multi-use. So what you'll see here is that we can actually detach our platforms. We can detach them from the sprayer, and we can put another tool on. So we've got tools like weed detection, weed spraying, mowers, all sorts of things coming. And that's again about making the right return on investment, because a single-use machine makes no ROI sense for a grower, but when he can use it for multiple tools multiple times, it really makes a difference. This is an animation, but essentially all you have is a single plug from that spray unit to the motor unit, and that's it. And then just unclip 4 things and take it off and put your next tool on and plug it in. So very simplistic for a grower operator. All our work is done on path planning in the orchard. So we fly a drone once for the customer. We use LiDAR and visual drone flying, and then all that data is fed into a path planning system that's set up within the software UI for the customer. Once that's in there, you've got multiple functions where you can do all sorts of things. If you've got a busy road and the robot's going to be coming out of that row, and there's a busy road at the end of that row, you can just put a tag in there where it will slow down to 1 k an hour for that last 2 meters before it comes out, just to slow down and give that robot time to visualize if anything's coming and stop. So there's a lot of software. We run all the diagnostics, so we can be telling the farmer it needs an oil change. We tell the farmer you need to add coolant. So everything is simplified. So for an operator, it basically all just comes up on a screen for them. And when they're setting their spray dynamics, it's all very simple for them. And so that's the vineyard configuration there. And what we've taken is a really modular architecture approach to the technology. So we've just developed our own customized electric drive motors. So we have 6 of those, 4 main drive motors and steering motors. We've simplified all the software, all the encoder. It's all the same across the whole machine, so everything talks to each other really simply. And then we have the navigation computing brain. That's in a separate box. It's in out for those environments. It's in a die-cast box or a shell-cast box. Keeping it totally safe from the environment. We have air and liquid cooling in those systems. We have an electric box. And what that gives us the ability for simplicity of servicing. If there's a problem with the compute module or a problem with the electric module, we can just unplug it, swap it out, boot it up in 45 seconds, and the grower's still going in a really quick time. So it's all about, you've got to be thinking about that simpleness for the growers and how they use it and that end user. And then we have a simple 70 horsepower diesel motor that drives a custom built power generator. And so you can see this, and then we have the battery system. So we can actually run this machine for a number of hours electrically without the motor. So if we weren't running an implement, we could operate 8 to 10 hours a day if we were just driving the machine around scanning or doing something that wasn't driving a heavy power use tool. We have that you can drive it from its parking all the way up to the orchard electrically. The diesel engine just clicks in when power starts to draw. It needs more power draw, and it just switches on and starts to generate more power to keep running for longer operational periods. So what you can see from this architecture, it just means it makes it really, really simple for us to create a number of multi-purpose machines. So we're not recreating the brain, we're not recreating the electrical systems or power generation. All we're doing is a new chassis design and a bit of rotor molding for a tank or attaching a different tool. So you can start to see how we can use different formats of that technology quite quickly to solve multiple problems across multiple crops and multiple crop configurations. And that's what gives us the scale to be able to do this, is that modularity. So that's it. Any questions? Bright lights shining.
Thanks for the great talk and really cool products. I was wondering regarding sustainability. So most of the times when we develop these robotic systems, it's more about efficiency, right? So how can we make sure that the robotic systems are actually contributing towards solving a sustainable agricultural future? What's your vision on that?
Yeah, so that's essentially what we're doing now with using, we're moving into the sense and task now. So applying more sensors where we're just more accurately applying. So if you looked at that sprayer, as I mentioned, by accurately applying, we can reduce significant use of chemical. Industry standards is they generally apply like 100 gallons an acre or 2,000 litres a hectare. We can get that 100 gallons an acre down to 20 gallons an acre, because they've really just got a big blast sprayer spraying it everywhere. But once you can start to target things in a more accurate way, based on the density of the canopy, based on the number of fruit on the tree or the vine, that reduces things significantly. If you think about what we're doing with the power generation, we're reducing fuel costs significantly. We're reducing the amount of diesel being used by probably, I think, by about 60% less diesel usage on that machine. And as battery power gets better, or some of that technology gets better, we can simply take that engine out, put a battery pack where that engine is, or we could in fact convert that engine into biofuel or hydrogen, or so it gives us that flexibility at the moment. But the ultimate goal is that we're using clean fuels. The ultimate goal is we're getting down to the most minimal use of chemical, which is better for the environment. And then we've got a lot of other sensing technologies where we're looking at everything from where we can be detecting a lot of other things as we drive through the orchards, and then do different tasks as we go.
That was a great talk. Thanks. Very impressive. I guess what I was wondering is, as you go between countries, you have very different distributions of foliage, ground, what you see. like, are there any gaps, like with the, I guess, the learning side, like understanding what's going on with machines? Do you have to sort of retrain them quite often, or is there any sort of technology you wish you had that would make that a lot easier?
Yeah, I guess there's always going to be, as technology moves so fast, there's going to be things we can adapt. But the way we've approached that technology now is we can sense every wheel, we can sense everything we're doing in the machine. So, our machines are like a European Audi car. Each wheel is independent in terms of its sensing. We've got more control over that machine than a tractor. And actually, if you saw that video, we actually have a pivot in that machine as well. So if one wheel dropped into an irrigation ditch or a drain, all other wheels have got point of contact that just drives it through. And that machine can climb with a full tank. We can climb 20-degree slopes, and we can do lateral turns at 10 degrees. So we can deal with a lot of environments. So we've been very thoughtful. That, me being a farmer, I've sat on a tractor and been stuck before. So, there's been a lot of work in that. It's also a lot around the tyre choices. You would have seen in the next generation, we had a bigger back tyre. We're using sort of like trailable glow inflation tyres. So, we have to think about compaction, all those other things. So I think if there was things missing for me is it's more about thinking about the problem you're trying to get through, because these environments are different. So in some orchards, for example, we may have to have a track crawler sort of configuration for a drive system, or we might have to have bigger wheels or smaller wheels. It's more about just knowing what's going to work in each of those environments. But what we've developed there has been tested through a number of environments. I think it's really that, it's more about the software control systems and the sensing systems that can really, is where I think the real gains will continue to come from.
Steve, thank you. I love these examples, and I'm curious to have two questions, if I may. The first is in the cases you're showing about the logs, and also as you're spraying, is there an effect of is there an element of inspection that goes on as well? In other words, analyzing the quality of the wood or the quality of the orchards as you're doing these other jobs. And the second one is, if you could say a little more about the financial model. A lot of people are talking about robots as a service,
yep,
which is what you're saying. And can you explain a little more about how that leads to recurring revenue, and what's the value of that in terms of a startup?
Yep, all good, really good questions. So in the logging industry at the moment, we just scan and scale. We've got 2 new projects coming where we're doing full log volume as well, because a lot of logs are weighed, and weight is a really subjective problem with logs, because if it's wet, it's heavier. If it's dry, it's lighter. So you'd think being able to do the volume on those logs coming in the trailer is actually simple, but it's not. It's a hugely complex mathematical equation, because even though you think the logs they're stacked like this end doesn't necessarily match with that end when you're taking images from either end. So it's a huge, complex. And we have to unload trucks and reload trucks and build those algorithms to do that. So we're looking at volume. Then we've been working with the likes of Scion, which is a forestry institute here in New Zealand, to look at sensors around wood density and wood texture. So if we can start to then, for that log, we can give the exact volume of that log, we can give its log density, we can give its millable timber. And in fact, what's really interesting is we sell the logs based on the small end. When the logs go to China, they measure the large end to then calculate the waste that comes off, which they sell. There's a lot we can be doing with logs, but just even in port logistics in its own right, with Cube, we're now taking that technology and doing things like scanning cars. They have 1.2 million cars a year shipped into Australia, and every car has to be inspected for any damage for insurance claims. So they now can drive through one of our scanners at 30k an hour. We image the car, apply the algorithms over, and give them a report on any damage on the car. We'd then move on to containers on trucks, because someone has to pay for damage on containers. And there's a lot of opportunity in this, that's sort of all that sensing a whole lot of different things happening in the environment. So there's a lot of exciting opportunities there. And then in terms of the orchards, with that autonomous platform, in fact, we can take a sprayer off. We've been designing a sensor rig that basically you take the sprayer off and put a sensor rig on, because trying to sense everything when you're doing a task is actually quite difficult, because you've got dust, you've got spray mist, or you've got things going around. So we're just going to actually a sensor stack that just gets put onto the back of the machine. So when it's not spraying, they can go and scan the orchard, and we can do it at much higher resolution. So we're, we've got the right lighting on the rig that we can actually light the whole environment correctly to really get good data. Then we can actually create maps that we can then feed into the system. So when the sprayer goes back through, we could be specifically, we could have pre-programmed that sprayer to spray these particular areas or these particular spots. So, that gets really interesting. And not only that, we can be, with hyperspectral and all these other technologies, we can be looking at chlorophyll levels and all sorts of things. And then it's how we bring all that data into decision-making support for the orchard managers. So we've got some big projects sort of in the background going on with all that. So essentially where we want to get is the robot is really it's a sense and task machine. It can sense an environment. It can make those decisions and just go and do its thing. So in terms of the ROIs, I don't think there's any one model that I've seen. I think you've got to be open to multiple models. When we travel around the world, we have customers that want to own the hardware because there's depreciation and other things, or tax grants or credits that are valuable to them. So they don't want it as a service. They want to own the hardware. So then under that model, we can sell them the hardware, but then it's charging them a subscription fee for that ongoing maintenance and updating of software and new insights. And then we can also charge them things like an hourly rate for every hour that the machine works. So, the concept of that is we want to make more money. We're going to give them more tools and more functionality to use that machine more, so we get paid for more hours. And then the upside for them is their ROI gets better because they're using the machine more. So it's finding those models that really work for each of the different situations. The forestry one was a really nice fit because we sell them the hardware. They funded the R&D up front and they had the prototype machine. Then we still owned all IP. Then we put that into a commercial machine, supplied that at an agreed margin because we negotiated on the margin on the basis that we could have ongoing royalties. For us as an early stage company, that's huge. We're getting the R&D funded, and then we've got the commercial model sold where we know exactly what our margin is, and then we've got a recurring revenue model. And the more of those we roll out, then we've got a nice revenue stream coming across on a regular basis. So I think what I'm seeing in the market is direct sale, robotics as a service. Generally, the word in the US is robotics as a service is really when you have failed to be able to actually give the grower a compelling proposition. So the startup ends up going and offering it as a service. Our approach is about, it's got to be compelling. We want them to buy it. Do we want to, as a startup, do we want to actually then go, how do we raise all the capital to own the hardware to then offer it as a service? So for us, we take the approach of we want it to make sense and for the grower to own it. And then we charge a value proposition on top of that. Yeah. And then some are sort of lease finance models. Again, having a partner like Yamaha, they have a huge finance division. So we can offer the grower a finance, but they still own it, if that makes sense. So again, it's all about thinking smart about your models, about how you're going to get that adoption and what's the easiest for your customer. I would say one thing. I was talking to you the other night about, I've seen a number of the ag tech startups fail because they really don't understand the value proposition, and they're trying to be too good. They're trying to do too much. So some of you may know a company, Abundance Robotics, that was harvesting apples. They got, they got no more funding and got wound up recently. Their challenge was they were trying to pick everything. and they couldn't get to this point of picking an apple every 2 seconds, because that's what you're up against. Labor can do pick an apple every 2 seconds, and they couldn't get to that mark, and they were also trying to pick everything. Whereas there was a lot of growers were just going, we don't need everything picked. You know, our challenge is we can't get enough labor to pick. If you could go through with your machine and pick 50% of that crop, you've just halved my labor requirement. That's all we need. So, you know, think about speed and just actually be able to get, that's what people are looking for, is those, we don't need everything replaced. We just, you know, we generally have a percentage shortage of labor. We've always got some labor, but we don't often have enough labor. So if you could do 50% of what that labor is doing, and do it really efficiently and quickly, growers would adopt that technology. So you don't actually need to think that you have to solve every problem. You can actually solve really basic problems. And what you saw in there is we had a basic sprayer that everyone already uses as our first sprayer. Now we're offering an upscaled sprayer now that is smart and can save a whole lot of other things. So it's thinking about those simple models to get adoption and then add complexity as you go. You know, you don't, and I think that's a really good thing people have to think about, that people are too complex to start with. Just think the basic things. That's all people want, is a basic solution. And then you can keep adding value to that. If you actually try and solve the real value thing up front, you've got nothing more to add later. And I think that's something to really think about when you think about your startups. Thanks.
Thank you so much for the wonderful talk. So I think following on, you've already answered my question partly, but following on from the talk about putting a sensor platform out there in the farms. So it seems like there's a real opportunity here for a data product as well as a physical product, you know, early recognition of diseases or blights, or understanding how decisions that they've made have influenced productivity on the farm, or, you know, even scaling up towards the predictive level,
Yep.
where you could sort of say, like, you know, here's how we think changes you've made based on early, you know, feedback are going to impact your long-term crop, you know, performance, viability. So I'm curious if sort of you're looking to push that sort of data platform resulting, or like, you know, data product or data as a service, you know, which is sort of coming on the back of this, putting these, you know, sophisticated sensor platforms out there in the fields.
Yep. No, we're certainly heavily involved in that, and you did right. So, you know, as with Robotics Plus, we collaborate with other people as well. So we work with, you know, AI business intelligence platforms. So they're looking at historic data, connecting it with weather data, and then being able to do predictions based on historical data and past weather data based on current weather data. And then we then we can feed metrics from what we're sensing in the orchard into that model. And then that's giving really high intelligent business insights to the business. And the things we're thinking about there is, you know, from a sales and marketing perspective, knowing what your crop is, what size your crop is hugely important, you know, because you can be a lot more well planned when you're going into your selling season. Fruit is you know, is a thing that comes once a year, and quite often it's a huge guess about what size, what the quality is going to be like, what the volume is going to be like. So how do the sales teams go out and sell on that basis? Secondly, huge cost in packaging materials. So, you know, if you saw those apples being packed in a tray, every tray is a different size for different size apples. So if you get your yield prediction wrong in terms of a fruit size, you can be left carrying millions of dollars of stock in the pack house. And then on the orchard, there's all those things from early disease detection to actually having an early insight to how many flower buds have I got, how much fruit have I got, what size is it, how's it tracking through the year in terms of its growth size. So you're absolutely right, and there's a lot of work, and that's definitely, we've got a lot of programs in the background doing exactly what you were asking. So a lot of opportunity, it's important, but getting people to pay for data is still a challenging thing. A lot of people actually don't know how to value what they don't know. And so, you know, it's an ongoing challenge.
Thank you very much. Can you give another round of applause? Thank you.